If you are coming from Windows environment, the way that Linux represents and manages storage devices will look rather different to you. So you already seen that the file system has no physical representation of the drive like C, D or E system in Windows, but rather has a file tree structure, starts with slash at the top here, or the root here of it. So this chapter takes a look at how Linux represents storage devices such as hard drives, flash drives, and other storage devices. We first look how additional drives and other storage devices are mounted upon the file system, leading up to the root here, and root directory mounting in its context simply meaning attaching drives or disk to the file system to make them accessible to the operating system. So for you as a hacker, it's necessary to understand the file and storage device management system, both you on your own system and out on the system of your target. So hackers commonly use external media to load data, hacking tools, or even their operating system. Once you are on your target system, you need to understand what you are working with, where to find confidential or other critical files, how to mount a drive to the target, and whether and where you can put those files on your system. So we will cover all of these topics, so plus how to manage and monitor storage devices in these lectures. Actually, I think this lecture will be one or two lectures, so no more than two lectures here in file system about Linux. So actually, I want to show you an image from internet here. So we begin with directory known as dev here. DuckDuckGo here. So we begin with the directory known as dev, which you probably already noticed in the directory structure. So dev is short for device, and every device in Linux is represented by its own file within dev directory. So let's start by working with dev, but I want to show you the Linux file structure. Linux file structure here. Can you see my screen actually? Yes, right? Yes. So here I want to show you a little representation for presentation for better understanding here. Here. Actually, it's good too here. So I choose two pictures for you here. So let's open this as well here. So here, as you can see here, we have the root directory, all of these folders here, and we have boot. As I said to you earlier, all things in Linux is file. So we have boot directory, bin, dev, etc, home, lib, lost found, media, mount, opt, sbin, serve, tmp. We have user, which is the usernames of our users, and we have another local here as well, and we have var here. So boot, as written here, boot is the system files including kernel. Bin is binary for user. Dev is device files and drivers. etc here is host specific configuration file. Home is user home directories. Lib is shared libraries, kernel modules here. Lost found is unknown files. So media is here. Mount points for removable media. MNT, mount point for temporary file systems. We have OPT here is optional software packages. SBIN here, system binaries. SRV here, data for services provided by the system here. TMP, temporary storage space. User applications like source code, images, and etc. We have in user we have local share sbin and lib folders inside it. So local is installed for local user, share is config files, graphics for user applications, sbin is essential system applications that for user here, and we have bin, which is user commands, and lib is shared libraries by user. So we have, lastly, I want to talk about you is var here. Var, we have var run, log, tmp here. So var here, variable data used by the system, run is info about current boot session, log is log files, log is log files, and tmp long-term or large temporary files here. So we have another representation here as well that I want to show you is a boot dev here. We talk about them. And as you can see, we have this scheme here. So first, I want to talk about is the dev directory here. So Linux has a special directory that contains files actually representing each attached device. So the appropriate name is div directory here. So actually, let's here. So we are the top of our file system here. As we discussed earlier, bin, boot, dev, etc, home, lib, like media, mnt, root, run. If you are not using Kali or Ubuntu or another system, yeah, these folders might different on your system here. So as your first introduction, navigate the div directory, cd div here, and ls here. So as you can see here, we have so many folders in it. So I will explain all of this here. So you should see something like that, or let's lsla here, as you can, or ls actually lsl is okay. So as you can see here, we have so many folders in it. tte here, we have port here, null, part port, pc, aux here. So I will talk about all of them. So the devices are displayed in an alphabetical order by default. So you may recognize some of the devices such as CD-ROM here, CD-ROM here, CD-ROM here, and we have CPU here as well, charge core here, CPU DMA latency here. So but others have rather cryptic names here. So each device on your system is represented by a file in the div directory here. We are working with it. So including devices you have probably never used or even not realized they existed here. So the of Chengyu 2, so there is a device file waiting to be used for it. So if you scroll down a screen a bit, you should see more listings of devices of particular interest. Are the devices starts with SDA or STB here. Is it like SDA, STB, and other here? As you consider SD1, SDA, SD1, SD2, SDA1, 5 actually. So SDA, SDA1, SDA2, and SDA5. So which are the hard drive and partitions used, and USB flash drive and partitions here. So I have not attached USB drive to this system. So if you attached a USB system, I think it will show you STB here. So STB1 or STB2. So how Linux represents storage devices. So Linux uses logical labels for drives that are then mounted on the file system. So these logical labels will vary depending on where the drives are mounted. Meaning the same hard drive might have different labels at different times, depending on where and when it's mounted. Originally, Linux represented a floppy drives. Remember this, right? So as FD0 and hard drives as HDA. So you will still occasionally see these drives representation on legacy Linux system, but today most floppy drives are gone, thank goodness here. And even so, all legacy hard drives that use the IDA or EIDA is interface are still represented in the form of HDA. So newer serial ATA or SATA interface drives and small computer system interface SCSI hard drives are represented as SDA here. So drives are sometimes split up into sections known as partitions, which are represented in the labeling system with numbers, as you will see here. So when systems have more than one hard drive, Linux simply names them serially by incrementing the last letter in alphabetical order. So the first drive is SDA, so this means I have one drive because I don't have SDB here. So and the second drive is SDB if you have USB, and third drive is STC, and so on. So the serial letter after SD is often referred to as the major number. So we have drive partitions here as well. Let's look at actually. So I will stop video here. So I'm waiting you in next lecture. Some drives can split into partitions in order to manage and separate information. So for instance, you may want to separate your hard drives so that your swap file, home directory, and root directory are all on separate partitions. So you may want to do this for a number of reasons, including to share resources and to relax the default permissions. So Linux labels each partition with a minor number that comes after the device designation. So this way, the first partition on the SATA will be SDA1. I want to show you here. LSL here. So let's find SDAs here. This which is my hard drive. If you had a second device attached to your computer, you will have SDB, SDC, SDD, or SDF, like that. How many files, that many SD and alphabet you will have. This way, the minor number, as you can see here, that this way, the first partition on the SATA drive will be SDA1. So the second partition will be then the SDA2, third SDA3, and so on here. So at times you may want to view the partitions on your Linux system to see which ones you have and how much capacity is available in each. You can do this by using fdisk utility. And fdisk utility, you can do this by fdisk utility and using L switch with fdisk lists all the partitions here, because we need give sudo permissions to this, sudo, and type your Kali password here. As you can see here, we have we printed all of our disks here. So as you can see here, the devices SDA1, SDA2, and SDA5 are listed in the first stanza. So these three devices make up the virtual disks from my virtual machine, which is 80 gigabyte drive with three partitions here, including the swap partitions, and which acts like a virtual RAM, similar to page files in Windows. So swap partitions acts like a virtual RAM. It's similar to Windows, like Windows using page partition for virtual RAM, right? So the swap partition is using when RAM capacity is exceeded. So if you scan down here to the third stanza, if you have external drive, you will see a second device output designed by SDB or STC here. So this can be your flash drive or anything here. So actually we can see our drives here with partition gparted application here, and you can run gparted like that and enter your password here. In my case it's Kali by default. As you can see, we can see our devices, actual partitions as well. It is the one device here attached to it, and as you can see here, we have 80 gigabyte, actual 79 gigabyte main system, root system. The second is extended, and the third is Linux swap, and 1 megabyte is unallocated. Here, as you can see, there is a dev SDA. I have one hard disk and no external hard disk attached to it. So something else to note about the naming of the files in the dev directory is that the first positions contains either C or B. So you can see here, for example, ls l here. As you can see here, C or B here. We will have, as you can see, there's a B here. So what this means? So this letter represents the two ways that devices transfer data in and out. So the C stands for character, and these devices are known, as you might expect, as a character devices. So external devices that interact with the system by sending and receiving data character by characters such as mice or keyboards are character devices. The B stands for the second type, block devices. They communicate in blocks of data multiple bytes at a time and include devices like hard drives and DVD drives and etc. These drives require higher speed data throughput and therefore send and receive data in blocks, many characters or bytes at a time. So once you know whether a device is character or a blocks device, you can easily get more information about it, as you will see next. So list block devices and information with LSBL key. LSBL key. So Linux, the Linux command LSBL key, short for list block here. List block here. This command lists some basic information about each block device listed in the dev directory. So the result is similar to the output from the fdisk L here. So, but it will also display the devices with multiple partitions in a kind of tree. So showing each device with its partition as breaches here, like that, and does not require root privileges to run. So as you can see, we have SDA and SR0 here. So the output includes the floppy, if you have floppy drive here, FT0, and DVD drive SR0. So this is my DVD drive here. So this is simply holdover for legacy systems. So we can also see information on the mount point of the drive here. As you can see, there is mount point swap, and there is the root directory, which is 79, almost 18 gigabytes here. And note that the hard drive SDA1 mounted here, root, and the flash drive, if you have, it will mount to media here. So you will see more the significance of this in next lectures, actually in next minutes here. So mounting and unmounting. Most modern operating systems, including most new versions of Linux, auto-mount storage devices when they are attached. So meaning the new flash drive or hard drive is automatically attached to the file system. For those new to Linux, the mounting might be foreign subject. So a storage device must be first physically connected to the file system and then logically attached to the file system in order for the data to be made available to the operating system. In other words, even if the device is physically attached to the system, it's not necessarily logically attached and available to the operating system. So the term mount is a legacy from the early days of computing, when storage tapes before hard drives had to be physically mounted to the computer system. Think of these big computers with spinning tape drives. You might have seen old science fiction movies here. As I mentioned, the point in the directory tree where drives are attached is known as the mount point. So the two main mounts in Linux are MNT here. Actually, let's What happened? Oops. I'm sorry. Display. Here. I'm sorry, 1 minute, please. Okay. Okay, we fixed it. So let's see the here. Let's mount this. When as I mentioned, the point in the directory tree where the devices are attached is known as the mount point. So the two main mount points in Linux are MNT and media here. Media. As a general rule, internal hard drives are mounted at MNT, and external USB drives such as flash drives and external USB drives are mounted at media. Through technically and directory can be used. So here I'm using VirtualBox. Actually, not. I'm using VMware here. So I will create a new USB flash drive here. USB controller, hard disk drive. This will be okay. Create virtual disk. It will be 0.5 gigabyte. Store disk as a single file. Okay. So in some versions of Linux, you need to mount a drive manually in order to access its content. So this is a skill worth learning to mount a drive on the file system. Use the mount command. So the mount point for the device should be an empty directory. If you mount a device on a directory that has subdirectories and files, the mount device will cover the contents of the directory, so making them invisible and unavailable. So the new hard drive, for example SDB, mount SDB1 at the MNT directory. You will enter here mount dev SDB, SDA or SDB1 and mount MNT directory. So for mounting, you will enter this following. So to mount MNT, you have to use sudo here, and SDB1 is not existed because it's I have not entered an SDB device here, or external drive, or a hard drive here. So the hard drive should be available for access. So if you want to mount a flash drive STC1 to media directory, you will enter this command here. So we can unmount our devices as well. So if you are coming from a Mac or Windows background, so you probably unmounted the drive without knowing it. So before you remove a flash drive from your system, you as you remember, when you right click on eject, it to keep causing damage to the files stored in the device. So eject is just another word for unmount here. So similar to mount command, you can unmount a second hard drive by entering unmount. Actually not unmount, you mount here, followed by the entry of the device in the dev directory here, dev SDB1 for example. And similar to mount command, you can unmount a second hard drive by entering unmount command here. For example, I entered SDB1 here. And then click enter, and as you can see, I have no such file or directory because I'm not mounted in this SDB1 here. So we can monitor files here. in this lecture as well, we will also look at some commands for monitoring the state of the file system. So a skill necessary for any hacker or system administrator. So we will get some information about mounted disks, and then check for and fix errors here. So storage devices are particularly error prone, so it's worth learning this skill. So getting information on mounted disks. So actually, let me show. Okay, so getting information on mounted disks. So the command df means disk free will provide us with basic information on any hard disks or mounted devices such as CDs or DVDs and flash drives, including how much space is being used and how much is available. Without any options, df defaults the first drive on your system. In this case, it is SDA, and if you want to check a different drive, simply follow df command here by your drive name. So we can check errors as well here. The fsck command, short for file system check, checks the file system for errors and repairs the damage, if possible, or else passes the bad area in to a bad blocks table to mark it as a bad. So to run fsck command, you need to specify the file system type here. Actually, I will not continue here. So you can in order to run it, first you should unmount dev stb1 or your file system device here, storage device here. So and then you can run fsck command here, which I will not run. So understanding how Linux designs and manages its devices is circular for any Linux user and hacker. Hackers will need to know what devices are attached to a system and how much space is available, because storage devices are often develop errors, so we can check and report these errors with fsck, and dd command is capable of marking the physical copy of